And there you got agricultural production and back to your algal system production. The products obviously from aquaculture could be sold, whether it's within the community or external to the community. But we know it's an important healthy protein source, fish are. And then the waste from this could be fed into an anaerobic digestion system. And I think it was our colleague from WRC, Prof. Sylvester, that actually mentioned the issues or the focus on anaerobic digestion and the links to the nexus. So as I said, we're going to talk about the aquaculture and the animal husbandry together. Livestock farming now becomes a reality because, as mentioned by Graham mentioned, the amount of land being used for meat production. And I have always, said that I don't believe, and I don't know how livestock farming works, but I don't believe we need that amount of land just for grazing. But if you could feed them a pellet that is got formulated to actually give them the necessary nutrients, you don't need that amount of land. But yeah, again, the animal protein could be a feed source for the animal husbandry. Your livestock can be sold for profit, but then the manure could be a feed in for an anaerobic digestion system. So now it starts to complete the picture even more. Okay, anaerobic digestion. I think this is an important technology that is probably going to be a household reality over the next couple of years, because it's easy to implement. It's low cost. There is some development areas, but I think it's getting there. So if you look at the animal waste that we generate in the process, the food waste, the domestic waste, can all be used to produce biogas, and this could be used for cooking, for electricity, for the communities, and for the mines. And it starts now to deliver the energy part as part of the nexus. What's going on here? So if you look at this, it's an integration between the process that starts from the mine impacted water, but it also gets in feed from the offices and the communities, which is essentially your human waste, your kitchen waste, your grey water systems, that allows for you to generate energy using an anaerobic digester. Concentrated solar power is another area. Now, the solar power generation is essentially broken up into two areas. It's concentrated solar power and your photovoltaic systems. So I'm focusing particularly on the concentrated solar power because of the generation of the amount of heat. Now, solar PV, on the other hand, is efficient in generating power, but heat is where you get a little bit more additional value when you're looking at an integrated system such as this. And yeah, you could generate power that could feed into the communities, but it also could be, support some of the mining activities. But more importantly, in concentrated solar power, you generate significant amount of heat. Now, in smelter operations, the temperatures in the smelters can be up to 2000 degrees. But using this waste heat or heat byproducts, you could preheat your smelter materials, which could reduce your energy costs required for smelter operations. Unfortunately, direct solar power is not going to get you to the 2000 degrees that you require, but it could help you get there and reduce your costs. The other thing is, and we spoke significantly about desalination over the last couple of days, and desalination is extremely costly. I think nobody can deny that. However, in a system where you've got waste heat, it does become a little bit more feasible because you can essentially evaporate at a lower cost. The biggest problem, and it's something that I highlighted yesterday as well, was that heat is not so much the biggest demand in mining communities or in a situation such as desalination. It's actually the cooling, because you can evaporate, but if you want to get clean water, you need to condense. So and this is something that I'm looking for people that have been working on, is looking at absorption cooling with that waste heat to at least deliver the cooling effects for condensing in the desalination process, but also to provide cooling in mining systems, because mines seem to need more cooling than they do need heat. So that just looks at it from that perspective. The other thing is from an environmental perspective. I think nobody can deny South Africa is quite bad when it comes to CO2 emissions. So yeah, we might not be the biggest polluter, but per person we probably right up there. And what we're looking at is carbon capture and storage using mine impacted water, where you could bubble CO2 through mine impacted water, and this is at its very infant stage of development at this point in time, and sequester your carbon in possibly potentially a high value product such as magnesium carbonate, for example. So I'm not going to go into too much detail here because it's a very early stage technology that we're working on. So I think what I've tried to present was how we could use a problem, which is mine impacted water, and demonstrate that it could be used in the circular economy. And the approach we've taken is one of cradle to cradle, where your waste or byproduct is never discarded but just reused within the system. And the aim is to minimize the impact of these polluted resources. And rather than releasing them into the environment to create further problems, we reuse them and we help create community value through jobs, food security, energy security. And although this is presented from a perspective for the mining community or for the mining industry, that picture itself could be changed. And you could remove different process operations and include new ones, and it could be adapted to various different scenarios, various different industries, to the rural community as a whole, to provide a sustainable community type system that generates food, energy, and job security. This is a very high level estimate that I looked at. Depending on the size of the mine, you could create between 500 to 200 direct jobs. I worked on a principle of 1 direct job to 4 indirect jobs, and that could mean up to 8,000 jobs created if this was implemented in the mines. And the whole idea here is, a lot of mines are coming, are going offline and reaching end of life. If you start to implement these types of systems now, when they get to the point where the mines close their doors, these systems are well entrenched, the benefits are noticed, and essentially you leave behind a sustainable solution rather than a big gaping environmental problem. Thank you.